maybe I will do a little bit of a tour for those people other than the 10 people that know what I'm talking about because they've watched all the videos. Actually, there's probably 5 people that watch all the videos, including me. We will start on this end. So here we have a 24-volt battery pack. There is 2 12-volt deep cycle batteries in series to give you 24 volts, and 3 of those pairs in parallel to give me 3 sets. It goes through a resistor, which is calibrated, roughly calibrated to approximately 1 millivolt, which is what I'm measuring, equals 1 amp. So the display shows me approximately amps. There's a contactor, or a big switch, and then we're just turning on the motor. So the motor has no throttle; it's just on. Okay, and then there's the chargers on that end that are actually charging up that one string of parallel batteries, and then the other string of parallel batteries. So the warp, net gain warp 9 here, with a target on the end for taking manual speed checks. It's a series DC motor, coupled with a joy coupler and some aluminum spacers between the warp 9 and the Siemens 1PV motor, which is an AC motor, which is wound for something around 200 volts. So those 3 wires you see, red, black, red, go into the motor. That's from the AC controller, which is right here. And it is fed from this larger battery pack, which is 1/3 of a Better Place or Nissan Leaf pack. 125 volts, or 128 volts nominal, I think is down to about 122 volts right now. And then we have a couple of meters. One is a clamp-on meter measuring approximate current. And then the other one is voltage across the pack. I've kept those as far away from the controller as possible. I did have them on that similar resistor to this down here, but the numbers were just crazy. They spun all over the place, and it was very unreliable. So I moved them as far away as possible. There's a little camera taking video of the meters. So the AC motor is directly coupled to the DC motor. Both shafts turn at the same time. There's an encoder on the AC motor, which is 64 pulses per revolution. You can actually tell which direction it's turning because there's 2 sets of pulses, and whichever one you see first gives you an indication of which direction it's going. This is an open source AC controller by Paul Holmes. He built it, he designed it. Incoming is 2 connections to the battery pack, here and here. We figured it'll do about 400 volts. Right now we're at 122 point something. Then U, V, and W are the output to the motor, and it sends out a bunch of pulses. Essentially looks like 3-phase AC to the motor, which then spins the direction it's told to with the torque that it's told to. This is the control board, nice big ring capacitor, and then there's 3 transistors underneath there. You can see the side of this one. They're IGBTs, and actually, maybe for this part, I'll switch to that one. There's a power supply over there, which is, we bring 12 volts in from this little utility battery, and it's using that to turn the contactor on and off. And then that power supply boosts up the 12 volts to 24, which is then used by the control board. And that is used to turn the transistors on and off as fast as possible. The faster you turn them on and off, the less heat they waste, because just the way they work. This is an emergency stop switch. It is normally on. So there's 2 sets of contacts, one on this side, one on that side. When this is pulled up, the DC motor is allowed to run and the AC motor is allowed to run. Signal here disconnects the power from the 12 volts. The signal on this side disconnects the power from this, which is the contactor. So when I slam that down, it kills power to both sides, which is useful. I have a laptop, which is connected to the controller through a serial cable, which is down here. And it lets me take a look at what the parameters are inside the controller, what the voltage is, how the throttle's set up. This is a throttle right here. It's a 20-turn potentiometer, so it gives me pretty fine control over what the speed should be and how much torque I'm trying to get. Old laptop, just using it to capture data. And yeah, that's about it.